What if we could warp space-time? The universe in our hands. Imagine standing at the edge of the cosmos, watching galaxies collide, stars explode, and black holes devour light itself. Now, picture having the power to manipulate the very fabric of the universe, space-time itself. What if, like bending a sheet of paper, we could warp space-time to travel vast distances in the blink of an eye, or even rewrite the rules of physics as we know them? Sounds like science fiction, right? Well, let's explore how much of this idea is fantasy, and how much could someday be our reality. What is space-time? At its core, space-time is the stage on which all cosmic events occur. Einstein's theory of general relativity revolutionized our understanding by showing that space and time are not separate entities but interconnected. Massive objects like planets and stars distort this fabric, creating what we perceive as gravity. The more massive the object, the greater the distortion. Think of space-time as a flexible rubber sheet. If you place a bowling ball, representing a massive star, on the sheet, it creates a dent. Smaller objects, like marbles, naturally roll toward the bowling ball due to the curvature of the sheet. This analogy helps explain how gravity works but also hints at the tantalizing possibility of intentionally manipulating space-time. How could we warp space-time? Wormholes, cosmic shortcuts. Wormholes, also known as Einstein-Rosen bridges, are theoretical tunnels connecting two distant points in space-time. If we could stabilize one, it might allow for instantaneous travel across the universe. However, current physics suggests that wormholes would collapse almost instantly unless held open by an exotic form of matter with negative energy density, a substance we have yet to discover or create. The Alcubierre drive. In 1994, physicist Miguel Alcubierre proposed a groundbreaking idea, a warp drive. This concept involves contracting spacetime in front of a spacecraft while expanding it behind, creating a bubble that allows the craft to move faster than the speed of light, without breaking Einstein's cosmic speed limit. The catch? This too requires negative energy or exotic matter, which remains hypothetical. Black holes and space-time distortion. Black holes are nature's ultimate space-time warpers. If we could harness their immense gravitational pull, we might bend space-time to our advantage. However, their extreme conditions make them more of a theoretical playground than a practical tool for now. The challenges of warping space-time energy requirements. The energy needed to warp space-time is astronomical. For instance, the Alcubierre drive would require more energy than is contained in the entire observable universe. Finding a way to reduce this energy cost is a critical hurdle. Exotic matter. Theoretical constructs like wormholes and warp drives depend on exotic matter with properties that defy normal physics. This remains one of the biggest unknowns in modern science. Causality and time paradoxes. Warping spacetime might allow for time travel, which raises paradoxes like the famous grandfather paradox. Ensuring that causality remains intact is a significant challenge. Technological barriers. Even if the physics checks out, the engineering challenges of building devices capable of manipulating spacetime are staggering. The materials, precision, and control required are far beyond our current capabilities. The potential benefits of spacetime manipulation. If humanity ever masters spacetime warping, the implications would be profound. Interstellar travel, reaching distant stars in moments instead of millennia. Exploration and colonization, expanding humanity's presence across the galaxy. Scientific discovery, unlocking the secrets of the universe by probing extreme environments like black holes or the Big Bang itself. Ethical and philosophical questions. With great power comes great responsibility. If we could warp space-time, how would we decide where and when to go? Could this technology be weaponized? Would it deepen inequalities, giving some nations or groups an insurmountable advantage? These questions highlight the need for ethical considerations alongside scientific progress. Are we close to warping space-time? While we're far from achieving practical space-time manipulation, researchers are making small strides. Experiments with quantum mechanics and gravitational waves offer glimpses into the deeper nature of space-time. Advancements in materials science and energy generation might one day make the impossible possible. Warping spacetime may sound like science fiction, but every great scientific breakthrough once did. From the dream of flying to exploring the stars, humanity has always pushed the boundaries of the possible. The journey to warp spacetime will be long and fraught with challenges, but it holds the promise of transforming our understanding of the universe, and our place within it. Are you ready to imagine the impossible? Because the future of spacetime starts with a single thought: what if?